Okay, this video looks at the vector or cross product, and we're going to learn how to calculate the vector or cross product. Now, a vector product occurs when the product of two vectors generates a third vector. So in contrast to our dot product, which generated a scalar. So A cross B, A multiplied by B, is the magnitude of A vector times by the magnitude of B vector, sine theta. Now theta is the angle between the two vectors, A and B. And this little n here, which you won't see in all textbooks, but that n is the norm or unit vector, which is perpendicular to the plane containing the two vectors A and B. And you'll see that in the diagram. Okay. So the direction of the resulting vector should be considered. Note that it won't always be considered depending on the textbook you're looking at. So if we look at the screws that I've presented here, if I'm going clockwise, the bolt is going in a clockwise direction, which you can see from the arrows there. That bolt is going to go down. Okay. In contrast, if we're going anti-clockwise, okay, so you can see the arrows going anti-clockwise here, that bolt will move up. Okay, so if we look at the diagram I have here, I've got two vectors A and B. If I'm going from A down to B, okay, that there is clockwise. Okay, so when I go clockwise, my resulting vector is going to point down. Oops. Okay, in contrast to that, if I'm going from B to A, so B cross product A, then I'm going anti-clockwise. Okay, and my resulting vector is going to be out of the page. So that's represented down here. So I've got, if the vector product A cross B, then I'm going from A to B, and if it's representing a clockwise motion, then the result is at all point down. Okay? If I've got B cross A, then the motion of B to A represents anti-clockwise, and it's going to point upward. So what that means essentially, when our positive and negative is just in terms of direction, is that A cross B is going to equal negative B cross A, because it's in the opposite direction. So if I look at a couple of examples, the first one says if vector P has a magnitude of 8 and vector Q has a magnitude of 5, and the angle between them is 30, calculate P cross B, P cross Q. So my formula, P cross Q, or P times Q, is going to be the magnitude of P times the magnitude of Q, sine theta, and our norm. So that's going to be 8 times by 5 sine of 30, which is going to be 5/8 are 40, and sine of 30 is a half. So 40 times by a half. So that's going to be 20. And because I've gone from P to Q, I'm going in a clockwise direction. So we're assuming this is P and there's Q, so that's an assumption. We're going to assume we're moving in a clockwise direction, so therefore this would be downwards. Okay, so we're assuming vector P to Q is clockwise. Okay, then the next one I've actually provided a diagram. So vectors P and Q lie in a horizontal plane as shown. Calculate the value of P cross Q. So again, my formula, okay, magnitude of P is 4, magnitude of Q is 9, 9, and then I have sine, and it's 45 is my angle. 4 9s are 36. Sine of 45 is 1 on root 2. So that's 36 on root 2, and my norm. Now I should rationalise that denominator. So 36 on root 2 times root 2 on root 2. And that's going to be 18 root 2. Now my direction from P to Q here is anti-clockwise. Okay, so this is going to be upwards. Okay, if you're a bit rusty on rationalising the denominator, that's 36 root 2. Root 2 times root 2 is 2. 36 divided by 2 is 18 root 2. So the next one, I have Q times P. It's just in the opposite direction, so that's going to be negative 18 root 2, or 18 root 2 downwards. Okay, so the exercise to complete, there are two that you can look at. Start with the Q Maths, exercise 1.4, page 27, question 1 and 2. Question 2 only do A, B, C, D. Now I'm pretty sure Q Maths don't look at direction. So the other one's Maths Quest, exercise 3B, question 1. So that one's on your Google Classroom. Now that one I'm fairly sure does look at direction.